Hello guys, welcome back. Always seems to be a delay these days in my camera for some reason. That's alright. I need to do some sort of donation crowdfunding project, donate to Paul's hardware setup. But we're not doing that yet. So yeah, welcome. Paul Tutors Maths. That's my name. And just keep subscribing to my YouTube. That's amazing. There's quite a few bits and bobs on there now. Also follow me on Instagram. That's tremendous. Keep posting solutions and bits and bobs there to keep everyone's brains working. You've had a long day. You've had a hard day. Let's just step it up a little notch. Just have a little sprint home to the finish to 5:30. Then you can go off and have your fish fingers and chips or whatever it is that you desire. Only thing I was to say is, it's just my hair as nice as it could be. Yeah, I was going to say tomorrow. Let's do. I was thinking of doing a bit of a free for all. So I want to know what questions you want to do. All right, so DM me on Instagram or contact me here on YouTube, whatever you want. If there's difficult questions, send me photos. If there's topics you want covered, let me know. And you can tell me tomorrow as well in the live chat. So let's do that. Let's put you in charge of your destiny. For today, I just wanted to cover a few uni questions. So I was looking at it with one of my students, just to get a feel for the transition from A-level into uni. And see what kind of questions there are there. And it did interest me. Of course it did. It's just what is the same and what's different. Of course you're going to learn new topics, but if you're doing physics or economics or biology, I don't know, any number of potential subjects where you're going to have a maths module in the first year, obviously if you're doing maths, these kind of questions will come up. And if you've done your A-level properly, you should know them. So let's start with this one first. I'm going to write it out. I'm feeling a bit tired today, so mistakes could creep in. You need to stay alert. You need to stay alert and let me know if there's anything that I get wrong. Yes, we can do statistics, Rachel. Yes, we can do statistics. It has been neglected. We did mechanics Monday. Stats has not yet happened. Okay, let's add it to the agenda. Maybe try and sneak that in tomorrow, but if not, by the end of the week. Right. Anyway, f of x equals 2 over 1 plus e to the minus x. So that's what we're dealing with. Just in terms of the question, anything weird there? It's just asked for the inverse. It said it's defined from negative infinity to infinity. I guess in university you're going to start seeing a lot more of that kind of thing where they tell you exactly what values of x it works for. But there's not too much extra detail there, to be honest. And really, we first learned this in GCSE. Because in GCSE there was a strategy to get inverses of functions. And this is how it went. You did y equals, well at least I did anyway, and then what I love to do is swap the x's and y's. Stop me if you've heard this one before. Bonus points if you know which band sings that song, but that could be a bit obscure. Oh, and I shouldn't have called that x, I should have called that y. So there you go. Okay, swapped it round. And then the point is rearrange it to make y the subject. So it's a little bit harder in this university one than it was in GCSE. Inverses don't crop up as much in A-level, actually, I must say. I'm sure finding the inverse function probably does crop up. It does crop up a little bit, I guess. Yeah, okay, no it does. Maybe I can take that back. I just seem to think of it even more at GCSE, they went really strong on it. Anyway, I've multiplied that whole bottom up. I'm dividing by x like that. I'm just doing algebra basically. Just doing nice, successful algebraic moves. Probably want to move that 1 across. And I guess here could be when you might start to panic, depending on what stage you are. Maybe if you're still in AS level, I don't know how much exponential, or don't know if this letter means much to you or not, or if logs mean very much to you. If you're in A level, then hopefully you've got a bit of a feel for how they work. But the bottom line is we need to do natural log of both sides. Natural log is the inverse of exponential function. That's what an exponential graph looks like. That's what a logarithmic graph looks like. They're inverses of each other, and inverse functions are reflections on the line y equals x. That's a bit of extra data. Don't really need too much of that right now. All I need to do is actually do it, do an extra step. Right, so it's doing the same operation to both sides. It's not taking sine of both sides, it's not squaring both sides, it's taking the natural log of both sides. If you take the natural log of the left-hand side, the ln and the e cancel because they're inverses, like I was saying. You get minus y. And here, the only thing I'm going to do is put that into one fraction. 2 over x minus, well, 1 is x over x, right? So therefore, that should be 2 minus x over x in there. Right, that's just doing this from back in our primary school days when we were young, innocent and free, and didn't know anything about differentiation. But anyway, we were able to do this. I probably didn't use the x's, probably used numbers, but right, talking too much. Times both sides by negative 1. I'm going to use a log rule here. Imagine that's a minus 1 at the front. That is the same as that. So this is again how much log work have you done, how much do you know about this kind of thing. Do you know this log rule? I've talked about other log rules before. This one has probably not been mentioned so far. If you've got something written like this with a power up there, and it's a log type thing, you can bring the power down the front. Or the other way around. So I'm doing it the other way around, and then finally, something to the power minus 1. Again, if you remember, well, let's make it 11 over 2 to the minus 1 is 2 over 11 to the 1, if you like. That just is 2 over 11. I mean, if something to the minus 1 a fraction, you're going to be flipping that. I can tell you now. All right, I can tell you now, or I can tell you tomorrow. But you will be flipping that. So you end up with x over 2 minus x. And I know I've called it x and y. You probably just have to re-jigify it into the letters that they wanted here. They're calling, this is where notation in university, you just start to think about it a bit. But I guess they're just calling the inverse instead of calling it f to the power negative 1, which you might sometimes see it written like that. They're calling it g of y, or actually I guess f to the negative 1 of x. They're calling it g of y, and it's in terms of y, and so you could just write it like that if you want. So to me, only option that can be is D. It's got to be the bottom one. Turbo recap. Not too crazy. Just GCSE invoices ramped up to the max. Not invoices. GCSE inverses ramped up to the max. There it was, presented to us. Changed it to y instead of f of x. I don't know, just easier. Don't have to write f of x every time. Swapped x and y. Rearranged to make y the subject. Probably the hardest part was, well, you've got to remember at times times that 1 plus e to the minus y up. That's mildly difficult. Maybe slightly more traumatic is just correctly taking the inverse of this exponential, which is natural log of both sides, and then the rest is history. History via a mild log rule of ln to the minus 1. So there you go, that's that one. It's inverses, but just souped up a little bit, taken to the next level. Okay, let's check this one out. So some have said, oh, can I get that nice one? Pretty good, there's not as much space to work with. I will survive. So consider the function that equals that, which of the following is correct. There's not too much to chat about here. It's just a case of getting the job done. So why don't you start it? If you're sitting watching this and you know what to do, then get going. See if you can beat me to it, because I'm going to be talking at the same time. If you don't know how to do it, maybe AS level, and you've not come across it yet, or you're just maybe, it's all right, we're all here to learn together, but you might not remember all your rules very well. Loads of people don't remember just very slickly all the different differentiation and integration rules. So maybe it's not one you've done for a while. Or you maybe can't notice it. But okay, the first thing I should say is I've already gone off on a big rant. But if you just let me write this out, then I'll say one more thing. And that is just notation. Derivative, differentiation. Another way of writing it, I'll just do that 3 lines, it's like, it's equivalent to, is f dashed x. So probably, just in case you didn't remember that or whatever, I'm here to just give you a gentle reminder nudge. So, and you probably see, I don't know, you might see a bit more of that at university. I feel like the f dashed x notation is used a bit more often. That's my feeling. So they've used it here. It's not an inverse, it's not f inverse or something like that. It's derivative. So they want us to differentiate this thing. There's something on top, there's something on bottom. It's a fraction. It's the quotient rule. Something called the quotient rule. If you've not seen it, I'll just talk through it anyway. If you have, you should be miles ahead of me by now. It's just a plug and go rule, and you get it in the formula sheet. I do think you get that in the formula sheet. I mean, wow. And it's going to say something like, if you've got, well, let me just write it. If f of x is u over v, then f dashed x equals, what is it, u dash v minus v dash u over v squared. Dun, 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 dun. So you're asking me, how different is this to A level? I mean, it just looks a bit different in that they've given you multiple choice and they've just directly asked you a question, whereas the new edXL papers are not going to probably directly ask you something. They're going to go in a roundabout way. But other than that, just a quotient rule question. Might get a bit messy, I don't know. We'll have to see how it goes. Just briefly explaining the quotient rule then, and what this all means. A dash means it's differentiated. So let me just write it out a bit more explicitly. The thing on the top of our one, you know, the numerator, is x squared minus x cubed. The thing on the bottom of ours, and maybe I'll just multiply it out, is 2x plus 2. Okay, so that's our numerator and the denominator, which we're calling u and v. Then I'm going to get u dash and v dash. Again, it's notation. It just means differentiating. You could call it dx by du. If you want to call it dx by du, I'm not here to stop you. It's nice to get used to that notation. There's not so much writing, less ink used. All right, more ink preserved for the generations to come. So what am I doing? Differentiating u, 2x minus 3x squared. And differentiating this chap is 2. Alright, maybe I'll try and shrink this question a bit so you can just see a bit more. Is that physically possible? Managed to pull something off. So yeah, there's the function. The top one's u, the bottom one's v. There's the rule, that's the quotient rule. It means if it's got that form, u over v, it's u dash v minus v dash u over v squared. So we need all these characters. This is the kind of play that's going to be on at our local theatre. It's got 4 different characters in them, you know, starring in the lead roles. Romeo, Juliet, Othello, and Hamlet. I'm not sure why they're all in the same play together. But it's just a case of finding them all. U and V are given to us. Just need to differentiate to get the other 2. Now we're going to plug in. So f dash x equals, now u dash is 2x minus 3x squared. V is 2x plus 2. Minus v dash is 2, and u is x squared minus x cubed. V, what is it again? Ah, there it is, 2x plus 2. So this is why I hope you had a pen out and you were giving it a go and you were trying to plug in the stuff. Can get a little bit confusing with all these 4 things here. Can you get the right things in? Hope I have done. Continuing. Doesn't look like anything we have there right now. So I think I'm going to have to multiply out 4x squared plus 4x minus 6x cubed minus 6x squared minus 2x squared plus 2x cubed. So it feels like to me. We'll just multiply out the bottom as well. Yeah, let's do it. 4x squared plus, now you'll have 2 lots of 4x, so it's plus 8x, and plus 4. Tidy up the top. What have you got? Looks like you got minus 4x cubed, and then x squared, you'll have minus 8, so again minus 4, anything else, plus 4x, all over that. So actually this has turned into, it began with just quotient rule and making sure you can plug it in correctly. It's kind of morphed a bit into excessive algebra. And can you correctly get that negative sign? Negative and negative makes positive. 2x cubed. Can you multiply that out correctly? No mistakes I'm hoping for. I mean, I'm saying that now, maybe I've made a mistake and these words will come back to haunt me. But if not, I've ended up with that. Do you know what I'm liking here? I'm liking divide everything by 4. I mean, everything's got a 4 in there, so do it how you want. You can either just, you could say times top and bottom by a quarter, or I don't know, however you want to actually convince yourself that you could just divide everything by 4 here, because every single term's got a 4 involved, or a factor of 4. So if you did that, minus x cubed minus minus x squared plus x over x squared plus x plus 1. Top row, you can take out a common factor of x, or actually I might just take out minus x squared plus x minus 1 all over, and that looks like x plus 1 squared, doesn't it? On the bottom, yeah. X squared x plus 1 would factorize like that. Does that match with anything that we've got there? C and A are very similar. But C has got 1 plus x squared on the bottom. So this is C. Turbo recap. Presented to you. Similar to integration questions like the one we did yesterday, if you want to go back and check out yesterday's live maths, what date would that be? 21st of April? There's an integration one. They don't tell you how to do it. Probably it's going to be the same in A level. It's going to be the same at university. Just get used to them not telling you which way to do it. If it's integration, is it substitution? Is it by parts? Is it reverse chain rule? Is it partial fractions? We need to start to be sort of slick on that. Differentiation, is it chain rule? Is it product rule? Is it quotient rule? Is it some other little trick that you've got up your sleeve that you've been hiding away, not telling anyone about? Assess situation. If it's a fraction, it's quotient rule. The word quotient, does that mean fraction? Pretty much. Someone check a thesaurus and get back to me. Quotient rule. Something over something. That is the rule. Probably won't be offered to you at university in this kind of course. Can't 100% guarantee. It is offered to you in A level in the formula sheet. Top one's always U, by the way. Bottom one's always V. And you know what? Then you have to sort of make up this little section of life, like I was saying, the key characters who are going to take part in this play. And then it's a case of plugging them in, carefully plugging them in. Remember, U dash notation, that just means du by dx, and v dash means dv by dx. And you know, you might have your own way of writing this as well. I'm never here to dissuade or discourage anyone who knows quotient rule already, who does use this notation or writes it slightly differently. It's a big world. There's room for all of us. I just quite like this way. Putting that underneath 522, can we bust out this last question? Turbo speed. Again, this straight to the point question. I'm not saying they'll never put you into difficult situations in university, but I do suspect your maths might be a bit more direct like this. It's possible. I don't want to go too far on saying that, but certainly there's a lot of situations, a lot of test questions which are more direct. It's just here's a function, get this. So here's an example of that. F of x equals. Yeah, and this is something that made me a little bit upset as well when I first started seeing this. I don't know if it's just they can't or they don't like to write it as a power, or it's difficult in the word processing. That is really the same as e to the x ln x. It's e. They call it exp here and then put a bracket on it. So you might just think that's normal and you've seen that before. But to me it was just a little bit upsetting for the first few times when I had to process in my mind that this was the same as what they're saying there. Anyway, bottom line is you've got options here. You could kind of just, I know some people just like a quickie differentiate the exponential, and you might think, I mean, just by the way, if your exponential is 101, derivative of an exponential, you just multiply the thing there down the front if it's like that. That's exponential differentiation 101. And look, I used this notation for you as well. Just there you go. See, I can be flexible to the needs of others. But that 4 just comes down the front. And more generally, what you would do is if y equals e to the sine x, I think you'll find you just end up basically differentiating the thing that's up there and multiplying it down the bottom. So derivative of sine x is cos x. So really that should be right as well, unless I'm very much mistaken. So that's exponentials 101, and of course you could, that's what I'm saying, some people might just jump straight to this and differentiate the thing up there, and I think you'd be right to do that. What I just want to do though, is I want to do what this rule is. Last one was quotient rule, this one is chain rule. It's chain rule because it's a function inside another function. Here's the bigger function, and here's the other function that's inside that. I'm not going to write other function there. I'm just going to keep those there to show you that the exponential thing is the wider thing, and within that there's another. So as soon as you got that, you've got chain rule. This is how I would do it. And let's say we're calling that y. And I actually really would advise you to get used to writing it out like this for university, since this is a university-based live maths or university prep type thing. It's use of A level for uni. They do, or it does crop up a lot more in this form, formally using the chain rule. Get the same result as over here, but this is what it looks like. dy by dx equals du by dx times dy by du. That's it. And it's not so bad to remember. I obviously need to go through it and just, if you've not seen it like this before, you might be shocked. And there are other ways to, anyway, there's some sort of other way to do it where you do u and then v and then u dash and then v. Some people might know this method. Again, that's fine. But I would, especially if you're comfortable with this method, I'd advise you to have a good look at this. Because this is the story. So, right. The thing inside we call u. That's it. Everything, that's the one little creative piece of art that we need to do here. We just call that u, and then everything else should fall into place. So u equals x ln x. And by the way, that means, if that's true, it means that, maybe I can write it here, y equals e to the u. See what I'm saying? If that's u, well, you got what that's now, instead of, it's just e to the u. And I'm just writing what my u is, x ln x. Differentiate it. Probably do the bottom one first, actually, because that doesn't change. The derivative of e to the x, or e to the u, is just e to the u again. Same thing. Unchanging. That's the beauty. I mean, that's what's special. I'm not going to say, okay, no long rant, but that is actually why e is special, because its derivative is the same. You get me? E to the x. So if you look at an exponential graph, if you choose a point on it, the y coordinate, so if the y coordinate of that point was 2, is the same as the gradient of the tangent at that point. You get me? That's only true for if it's e is like 2.7 something, isn't it? Or 2.6. It's just a number, but it's a special number such that on the graph of e to the x, the y coordinate equals the gradient. Huge distraction. Differentiated that. How am I going to differentiate this one? Well, I'm not going to write out this formally because I do think the chain rule is more important, but this one is the last differentiation rule. It's the product rule. It's two things multiplied, and so that's going to go to 1 times ln x plus x times 1 over x. Let me just quickly explain that. I don't really like to do the product rule in... I know you're going to have to do it formally and write it more quickly, but just as an introduction and generally, it's quite intuitive. It's just you need to, if it's two things multiplied, you differentiate the first one, keep the other one the same, plus keep the first one the same, differentiate the other one. All right, so you've got two things multiplied. You'll end up with two terms. The first one, leave one of them undifferentiated, do the other one, and then your second one, differentiate the other one. By the way, derivative of ln x is 1 over x. But you knew that. So that's that one done. So not much left to do. Differentiated my u equals, I've differentiated my y equals in terms of u. Now let's just plug it into the chain rule. So it's got to equal du by dx times dy by du. Well, du by dx is ln x plus 1. You'll notice these x's cancel. And the other chap, dy by du, is e to the u. Why don't I just put the u back in though? Well, no, I'll do 2 lines of working. And so yeah, my u from earlier, from my substitution, I can sub it back in now. It's x ln x. Cool. Then we look hopefully to the question, see if there's anything even remotely similar there, and it looks like it's probably A. They just multiplied it the other way. Doesn't matter which way you multiply it. 2 times 3 is the same as 3 times 2. Sorry if that's just news to you, but it is. So let me just check there's nothing gone wrong. Yeah, looks like it's A. Looks like it's 18. So we'll recap. Final one. Oh, we went a bit long today. But that's okay. It just acts as a good way of keeping on top of the key rules for differentiation. That's why I quite like this work. They gave us that. We could have cheated because you can just differentiate what's in the top bit and stick it down the front when it's an exponential. But we were bold, we were ambitious. We thought, chain rule, let's get a feel for it. We use it when there's a function inside another function. Doesn't have to just be exponential, works with sine, works with polynomials, x squared, x cubed. Come up with a function, name it after yourself, and it'll still work. That's what it says. Not that crazy to remember because it's just saying the derivative is, well, imagine cancelling those u's out, and then you'd just be left with dy over dx. It's just like sticking in a couple of extra du's for a laugh. And then it's just an art of choosing the right u. It's the thing inside. That can be difficult. People find that difficult. It's like, what is u? So you need to make sure you're slick on that. It's the thing inside the brackets. Once you got that, differentiate it. Now this is product rule. If you like, call that u and v. Then it's u dash v plus v dash u. If you want to write it out. Let's just u dash v plus v dash u. If, well, no, I'm not going to, let's not write it all out formally like I did the other ones, but that's what product rule looks like. So you get that, differentiate that, it's the same as itself, multiply them together because that's what the chain rule's telling you to do. You know, take that, multiply that, and you get your answer. That's it. Cool. So I like that. I like that because it's just, like I said, covering the key rules, getting you ready for first year. Is it easier than A level? Is it harder? Are they the same? I'll leave that to you. You can let me know if you've got any opinions, but I presented it how I've seen it. Thanks very much, guys, for tuning in, for watching. Back in action tomorrow. Hit like on this. Keep subscribing, keep commenting, keep challenging me. If you've got any homework problems or any issues with work you get given from school, send them to me. I will have a little look at it, see if I can help or not. You're very welcome, people. Loving it. Have a nice evening. Back in action tomorrow.